All right. So if you look on your periodic table, flip it over for a second. You have another reference table that you're going to be able to use on your test. And it lists something we call radicals. Okay? Radicals are also known as polyatomic ions. What does that mean? Polyatomic ions. So poly means what? Many. Atomic? Atoms. So many atoms. Now you probably don't know what ionic means. It's a chemistry term. What did we say? Normally an atom has what charge overall? Neutral charge. Because it has equal numbers of protons and electrons. Protons being positive, electrons being negative. There's equal numbers, they balance each other out, and overall the atom is neutral. But as we've been talking about, sometimes an atom can lose an electron. If an atom loses an electron, what does its charge become? Positive. It becomes positive. Lost a negative, so it becomes a positively charged. If an atom gains an electron, what happens to its overall charge? Becomes negative. We call those things ions, okay? Atoms with a positive or negative charge. So a polyatomic ion is a group of atoms, many atoms, with a charge. We also use the word radical to name these things. So this is a list of what we call radicals. And radicals are groups of atoms that kind of act together as a unit. So if you look on your chart that I just asked you to look at, NH4, ammonium. NH4 sort of acts at, now is it an atom? No, it's made of several atoms. But these atoms are bonded together and act sort of as one unit, just like a normal atom would. Okay? And so you have a list of common radicals, and it also on that chart lists their oxidation number for you. Okay? You don't have to figure it out, it's listed for you. Okay? They have a positive or negative charge. So these radicals can combine with other elements or other radicals to form compounds, just like any other atom count, and that's what we're going to look at here. So a radical is a group of atoms acting like a single atom. Okay? They have their own oxidation number, and you can look it up on your list. And they can form compounds. And when these radicals form compounds with other elements, we write them in parentheses because they're sort of acting as one unit. Okay? So, for example, nickel, is that an atom or a radical? It's an atom. Go ahead, look it up in your periodic table. What is its, let's start with this. What's its, how many valence electrons does nickel have? 2. Okay. So what is its oxidation number? +2. Now phosphate, we can't look up on the periodic table because it's several elements. But we can look it up on that radical chart. So phosphate, when you look it up on that radical chart, what is its oxidation number? Raise your hand, please. Caitlin? -3. And now, to figure out the formula for this compound that they're going to form, we just follow the same steps we followed if we had 2 atoms. We crisscross, the 2 comes down, 3 goes down, and we end up with a final chemical formula of Ni3. We keep the parentheses with the PO4, phosphate. So Ni3, PO42. So basically, you just treat one of these radicals as if it were an element, and you look up its oxidation number on your chart. In the next example, we have 2 different radicals that are combined. Ammonium and carbonate. So ammonium, what is its oxidation number, Rosen? +1. +1. How about carbonate? What is its oxidation number? Kimberly? -2. Crisscross the oxidation numbers, and what do we get for our final answer? What is the formula for this compound? Linda?
NH2, NH4, and then 2.
Yep.
And CO3, and then 1.
Yes. NH, we don't write the 1, but NH42, CO3. It's pretty simple, not too complex. In a few minutes, we're going to talk about naming compounds, how we give them names. But before we get there, I want you to sort of look at your radical chart. You notice some common suffixes for those.
Like, some of the last 2 letters are 8.
There's lots of 8s. What else?
Ites.
Ites. Okay. You see any pattern to what makes something an ATE and what makes it an ITE? It's not just sort of random. There's some logic behind that. Peter?
The amount of valence electrons?
No, not the valence electrons. Yeah.
Like, if it has 3 or 4, like that exponent next to it, it's usually AT, and if it's like 2 or under, it's usually IT.
Okay, you're getting there. We're close. Cece, what were you gonna say?
I was thinking even number get
No, it's not even or odd, but you're on the right track. It has to do with how much oxygen is present in that radical. Look at sulfate and sulfite. How does the amount of oxygen compare? Sulfate has how many oxygen atoms? 4. Sulfite?
3.
Look at carbonate and carbonite. Carbonate has 3 oxygen, carbonite 2. Nitrate? Nitrite? 2. So the 8 always has more oxygen, okay, than iron. So that's how they get those names. So when you see something that has an 8, you know it's going to have 1 more oxygen than the version with iron. Yeah. All right, we'll talk more about that in a few minutes. So here again is our periodic table, our radical chart. Okay.